Chapter 10.4. We're going to talk about inscribed angles and polygons. All right. Obviously, we're going to talk about what that word inscribed means. All right. So, we'll start with, what is an inscribed angle? Okay. And with that, we'll talk about what is an intercepted arc. All right. So I think first we'll look at a picture. So let's draw a circle. We'll look at a picture of it, and then it'll help to explain what the definition is going to be. All right. So, up until this point, we've only talked about central angles, which remember means the vertex was in the center. So now we're going to talk about what's called an inscribed angle. The difference in a central angle and an inscribed angle is that if this is an example of an inscribed angle, what do you notice is different? Well, the vertex is on the circle. Okay? So an inscribed angle is an angle whose vertex is on the circle. So what do you notice about the sides of an inscribed angle? Well, this inscribed angle. Well, here's a chord. If we were to stop here, okay, here would be a chord, and here would be a chord. So an inscribed angle can be made up of chords of our circle. Right? Now, we have what's called an intercepted arc. Well, as you can see, in this circle, okay, or in this angle, we have an arc in the interior of it. Right there. Okay? That is called our intercepted arc. So it's the arc inside the angle. Right? So this is our inscribed angle, and this would be our intercepted arc. Alright? So we've got a theorem. Okay, theorem 10.10. It's called the measure of an inscribed angle theorem. Guess what it's going to tell us? How to find the measure of an inscribed angle. Yep. Alright, so we'll use this angle here. Alright. So, if we want the measure of this angle, okay, the measure of angle BAC, what this theorem tells us is that the measure of our inscribed angle is going to be half the measure of its intercepted arc. Okay? So, the measure of an inscribed angle is always half the measure of its inscribed arc, which is different than a central angle, because remember when we talked about central angles were the same, their measures were the same as their arc. So, different. Measure of an inscribed angle is half its intercepted arc. Alright? So, let's look at an example. Let's say we've got this circle over here. Alright. This chord AB, BC, CD. Alright. Let's say that this is 40 degrees. Alright, and this is 90 degrees. Right, what we want to do first, we want to find the measure of arc AC. Okay, so we want to find that arc. we're going to do is we're going to look at its inscribed angle, which is 40 degrees. And what do we know about this angle compared to that arc? This is half of our arc. So that means our arc is going to have to be 80 degrees. Right? Because it would be twice as much as the angle. If we wanted to measure of angle BCD, we're going to look at its intercepted arc, which is 90. And we know that the angle has to be half of 90, which would be 45 degrees. Alright? Okay. Let's move on. We've got another theorem. Theorem 10.11. It's called the inscribed angles of a circle theorem. Again, we're going to look at a picture of it because it'll make it easier, I think. Okay. Now, what the inscribed angles of a circle theorem says is that, well, we'll just draw it. Let's say I've got this inscribed angle, ABC. And then I've got this inscribed angle, ADC. Okay? So what I want to do is, let's just look at ABC first, and let's look at its intercepted arc. So if I look at ABC, its intercepted arc would be arc AC. Right? Now, if I was to look at this other inscribed angle, ADC, okay, its intercepted arc would also be AC. So if they have the same intercepted arc, what do you think is going to be true about these two angles? They're going to be congruent. Okay? So that's what this theorem says, is that if two inscribed angles have the same intercepted arc, then the angles are congruent. Right? Okay? So, for example, say we've got this circle out here. Right? Got this angle, and we've got that angle. Okay. So we'll Q, R. Right. And they tell us that the measure of angle QRS equals 72 degrees. Right. Well, what we want to do, we're going to find the measure of angle QTS and the measure of arc QS. Okay. So they're telling us that QRS is 72 degrees. Right. Now what do you notice about QRS and QTS? They share an intercepted arc. So since they have the same arc, that means that they must be the same measure. So the measure of QTS would be 72 degrees. And we know that the arc is how much of the angle? It's twice as much. So our arc would have to be 144 degrees. Right? Okay. So Inscribed means the vertex is on the circle. Now let's talk about inscribed polygons. Okay. An inscribed polygon, well, if an angle, inscribed angle has a vertex on the circle, an inscribed polygon is going to be a polygon whose all of their vertices or all of their vertices are on a circle. So all vertices okay. For example, we have a circle. So we got something like this. That would be an example of an inscribed polygon, because all of its vertices is on the circle. Okay? This, in particular, would be an inscribed pentagon. 1, 2, 3, 4, 5 sides. Be an inscribed pentagon. All right? Now, this circle that contains all of the vertices, we call that the circumscribed circle. Right? Okay, so we're going to have a couple of theorems to talk about when it comes to these. All right? The first one is Theorem 10.12. It's called the inscribed right triangle theorem. So this is what I want you to do. I want you to draw a circle. Okay. And I want you to try and draw, or I want you to draw an inscribed right triangle. Okay? I want you to draw an inscribed right triangle. So if it's inscribed, all the vertices are going to be on the circle. Okay. So maybe something like this. Now, no matter how you drew your triangle, if you actually drew a right triangle that was inscribed, you should notice that the hypotenuse had to be a diameter. It has to be. You can't inscribe a right triangle where the hypotenuse is not a diameter. Right? Now, some of yours might look like it, but it ain't right. Okay? So, what this theorem says is that if a right triangle is inscribed, then the hypotenuse is a diameter. So, if you saw a circle and it had an inscribed triangle in it, okay, so let's say it had an inscribed triangle that looks something like this. Well, what do you know about that angle right there, x? It has to be 90 degrees. Okay? Because that's a diameter, so it has to be the hypotenuse of that triangle. Alright? Okay, one more. We got Theorem 10.13. Okay. Theorem 10.13 is called the inscribed quadrilateral theorem. It says that, not if, a quadrilateral can be inscribed, scribed, if and only if its opposite angles are supplementary. All right. Now let's think about how many degrees are in a quadrilateral. Hey, remember we did the whole n minus 2 times 180? And we talked about a triangle has 180, and so then a quadrilateral has 360. All right? So if the opposite angles each equal 180, well then 180 and 180 would be 360. So let's look at a circle. We'll draw an inscribed quadrilateral. Something like this. Alright? So, based on this, this theorem, the only way that this quadrilateral could actually be inscribed is if its opposite angles, so looking at the opposite angles, it would be A and C, and then B and D. So the measure of angle A plus the measure of angle C is going to have to equal 180 degrees. Okay? And then the measure of angle B plus the measure of angle D is going to have to equal 180 degrees. Which makes sense because 180, 180 would give us 360. Alright? So we'll look at an example of that, and that'll be the last thing for 10.4. So we got a circle, like so. We've got an inscribed quadrilateral. Right. Call this A. That's going to be 8x. This angle is going to be 2x minus 6. This angle is going to be 10x. Alright? Sorry, this is 2c, not x. Sorry, 2c minus 6. Okay, so we got A. That's an A, not C. Sorry. Let me rewrite this. 2a minus 6. There we go. Alright. So, let's look at these two angles first, because they're opposite. Well, this is an inscribed quadrilateral, so we know that the opposite angles have to be supplementary. So I know that 8x plus 10x has to equal 180. Right? So I would get x equals 10. So this angle is going to have to be 80 degrees, and this one's going to be 100 degrees. Right? Now, let's look at these two angles. These also have to be supplementary. So I'm going to say that A plus 2a minus 6 equals 180. Right? So I'd get 3a minus 6 equals 180. I need to add 6, so 3a equals 186. Okay? So then I take 186 divided by 3, and that gives me a equals 62. Okay? So if this angle is 62 degrees, this angle, we can just subtract 62 from 180, and 180 minus 62 would give us 118. So that angle is going to be 118 degrees. That angle is going to be 62 degrees. Alright? Okay, so inscribed angle, The vertex is on the circle. Okay? It has an intercepted arc, the arc that's inside. We know that the measure of the angle is half of its arc. Okay? If two angles have the same arc, then those two angles have to be congruent to each other. Right? If we have an inscribed polygon, that means that all the vertices are on the circle. Right? If we have an inscribed right triangle, then the hypotenuse has to be a diameter. Right? And then the last thing we talked about was if we have a quadrilateral that is inscribed, the opposite angles have to be supplementary. All right? Okay, that's it for 10.4.